Good afternoon, class. My name is Dominic, and I will be your instructor for this Electronic Devices 2. I believe in the curriculum you're already done with your Electronic Devices 1, which mainly tackles about the bipolar junction transistor or your BJT. I believe you already discussed with the characteristics, the types like the NPN and the PNP device, its construction, and all of the calculations relating to your bipolar junction transistor. Okay, so for our electronic devices too, the discussion starts with this very common type of transistor, which is your field effect transistor, or commonly known as your FET. Okay, just like your BJT, FET is also a three-terminal device that is basically like it has the same variety of application with your bipolar junction transistor, which is its main purpose for amplification. Okay, uh, if our BJT is controlled by the current that flows to its base, our field effect transistor, from the word itself, field effect, it uses electric field to control the flow of your current. Okay, so let's start the discussion with having the primary difference of our BJT or our bipolar junction transistor from our FET or our field effect transistor. Okay, as you recall, your BJT, you have here your three terminals, which is here your drain connected to your, sorry, not drain, which is your collector connected to your VDD. You also have here your base, and you have here your emitter connected to your ground. Okay, for our FET, since it's also a three-terminal device, you have here your drain connected to your VDD. Okay. You have here your gate for your input, and you have here your source, which is connected to your ground. Okay. From the word itself, bipolar, this transistor device is basically controlled by both your electrons or the negatively charged particle and your holes. Okay? But our FET, since this is a unipolar device, it is only controlled, okay, by either electrons, the negatively charged particles for your N-channel devices, or your holes for positively charged particles for your P-channel devices. Okay, so if this BJT, okay, the current that flows here to your collector, okay, is controlled by the amplification factor beta and the current that flows to your base. Okay, as you recall, your formula of getting the current that flows to your collector, you have your beta IB. Okay, so you see a linear graph when you plot here because your beta here is just an amplification factor of the direct proportionality of your base current and your collector current. Okay, whereas your FET, okay, the current that flows to your drain is mainly controlled by the field effect or the voltage, VGS, from your gate to your source. Okay, later I will discuss to you what is VGS. But for the sake of calculation, the formula of your drain current is defined by your IDSS times 1 minus VGS over VT squared. Okay, so we will discuss what is this IDSS, what is this VGS, and what is this VP in the calculation of our drain current.